right with you. And so as we speak, I am making a big final review so that you can kind of work through all of the questions that we've done this year, even though I've given you a lot of reviews for the different units already. So this one, you can consider it as all encompassing, right? It's not going to have everything on it, but it's going to get you pretty close to it. So let's come up with a question here. How far from the base? So these are what I consider shorter questions, right? They might get a little longer. How far from? Oof, what happened there? Try it again. How far from the base of the house is the foot of the ladder comma if the angle of elevation is 70 degrees and it reaches 15 feet up the house. Okay, so I'm gonna pause it here. You copy this. The diagram, it's talking about an angle of elevation. So you know your triangle is gonna look like this or like this, right? And this being the angle of elevation. So we're talking about a ladder, and we know that a ladder leans against something, right? So if this is the wall of the house and this is the ground, the ladder will be leaning against like this. So you should be seeing the right triangle that appears, okay? Now let's fill in the information. If the angle of elevation is 70 degrees, and remember angles measure opening between two sides, so it should always be between two sides on the inside of a triangle. Let me just talk about a few scenarios that may appear and the way they might word it. It could say that the angle of elevation between the ground and the ladder is 70 degrees. They're saying the same thing, okay? So don't let the wording throw you off. You know what angle of elevation is, you know where it goes, and that's how it is. So 70 degrees would go here. There's the ladder. It says it reaches 15 feet up the house. So is it the ladder or is it here? It is here, right? 15 feet goes right here. And it wants to know how far from the base is the foot of the ladder. So this is the base of the house. This is the foot of the ladder. They're talking about this side here. The same question could have asked you what is the actual length of the ladder, in which case your unknown would be here. But in this case, it's here. All right, so the 70 being here tells us that this is a reference angle. So we go across, this is your opposite, this is the adjacent. We don't care about the hypotenuse. So, okay, it's opposite adjacent. We will be using tan. So tan of 70 degrees, tangent of 70 degrees is equal to 15 over x, like that. You put the 1 down here so you know that you have to travel down, multiply, and then divide by what's left. So 15 times 1 is just 15, and this is tan of 70. So 15 divided by tan of 70, make sure your calculator is set to degrees. It's 5.46 because it's 459, so it turns to a 6, and we are in feet. So this is what they're after. Okay, so write it down if you didn't get it. No big deal. We're practicing. Just don't give up. Okay, at some point. So this would be a 2-mark question, right? 1 mark for the diagram, 1 mark for the work, and that's how it is. Okay. Or most likely it could be a 3-mark. Yes, I would do 1 mark for the diagram, 1 mark determining is it SOHCAHTOA, right? Is it sine, cosine, tan, and then 1 mark for the correct work. Okay. So if you get your diagram wrong, but everything else is consistent, you could still score 2 out of 3. Okay. Okay, next. Write this down, and I'm gonna leave the top there in case some of you are still writing the top part down. So write down the next question. This is one with an angle of depression, right? So this is important here for us because we know our triangle is either gonna look like this or it's gonna look like this, right? So the wording is rather interesting, right? How tall is a tower? So we know they want the height of the tower. If the angle of depression from its top to a point 75 meters from the base is 62 degrees. Now what you need to connect is that the angle of depression is 62 degrees. They put a whole bunch of stuff in between. But angle of depression is 62 degrees, right? The angle that we need is 62 degrees. And so let's draw our tower. This is the tower, very simplistic. And from the top, it's looking down to a point, right? We don't know if it's going this way or that way, it doesn't matter. So let's do that, right? So that is the point, which is, if this is the tower, this is the ground here, there's a 90 happening right there. We know that this is 75 meters away, right? This is the point that you're looking at. Okay, this is the tower. This is your tower representing a tower. And so this is where I need you to be a very close attention. So stop whatever you're doing at home right now. If you're distracted, this is where you need to pay attention because this is a very common mistake that students make. A lot of students, they would put the 62 degrees in here because, hey, angle of depression, it's going down. But remember what the angle of depression is. It is always, look over here, it's between the horizontal and the line of sight looking down. So the triangle should look like this, but you don't have that here. So what you need to do is I'm going to use a different color so that you can see it. You need to make a rectangle here. You need to complete this picture. So you go straight out and then you go down. And so you make your rectangle there. So this is also a 90 there. This is still the height of the tower. It's just transferred over to here. This is still 75 meters here, right? That's the distance along the bottom, just transferred over to there. So the angle of depression goes in here. That's where the angle of depression goes. Okay, so you need to complete, I will say, make a rectangle. Okay, make a rectangle. And that's where the angle of depression goes. It does not go here. Okay, this is not depression. We can't fit angle of depression in there. Okay, that is not angle of depression. It is this. It's between the horizontal and the line of sight looking down. Okay, always remember that. I hope you will. So we basically work with this triangle here. So I'm just gonna draw it out. Just sketch it. It doesn't have to be perfect. So this is 75 and this in here is 62 degrees. And they want the height of the tower, which is represented by this side here, right? This height of the tower is transposed to here. So this is my unknown. So you label, this is opposite. This would be the hypotenuse. I don't care about it. This is the adjacent. Okay. So O and A, that's tangent, right? Use TOA, right? If you want to write it down like that. So we're going to go tan of 62 is opposite over adjacent. You can put the 1 here, but really you're just multiplying by 75 times tan of 62. And that will give you 141.05 meters. That is the height of the tower. And now they could have asked you how far, what's the direct distance from the top of the tower to that object? Then they would be asking for the hypotenuse. Okay, so be ready for, I can't give you every possible scenario, but I can talk about it as we're solving. Okay. Now there's a bit of a trickier one. So be ready for that. Just keep copying down, okay? You can go over it later as well. So make sure you have this written down. I'm going to slowly move this up so you can start copying that question here. Okay, so start writing down that last question that you have. I'm going to pause my recording here. I would put a star next to this one because it's a little bit more challenging. Okay. So when sand is piled onto a flat surface, it forms a cone. If the pile is 8 meters wide and the angle between the ground and the slope of the pile is 28 degrees, calculate the height of the pile. So you almost have to imagine, you know, a pile like this, right? And it's just going, the assumption is it's a symmetrical shape. Okay. So the height of this triangle, of course, would be going right down the middle like this. And we know that this pile is 8 meters wide from end to end, right? The pile of sand. And that the angle between the slope and the ground is 28 degrees. Would it be 28 here as well, Mr. Dirksen? Yes. Like normally when you pour sand, right, it will be symmetrical, it will be the same on either end. So we can put down 28 here if you want. And this is what they're asking us for, right? Like what's the height of this pile? Now you can't work with non-right triangle, right? Oblique. So we take one of the sides, okay, take it out and make it into a right triangle. What's going to happen to this 8? You're going to have to divide it by 2, right? Divide that by 2 and you get 4 meters. So that's the trick there. and this is 28 degrees, and that's x. So this would be opposite, hypotenuse we don't care about, adjacent. Could you find the hypotenuse after? Yeah, you could find it by using trig again, or by using Pythagorean theorem. So this would be O and A, which is TOA, right? So tan of 28 degrees is going to be opposite over adjacent. So it's 4 times tan of 28. And what is that? 2.13, because it's 2.126. So it changes to, it rounds to a 3. That is the height of the pile. Okay. So then you've done that. So this was the trick here, to split it in half and get the half of the base basically to work with that right triangle. And it only works with a symmetrical. This would be an isosceles triangle, right? Because those two sides on the slope here would be the same. Okay, so that's that. Now I'm gonna pause this. Well, maybe not, because if you watch it, I want you to do, I will say this, work on sine ratio, cosine ratio, tangent ratio worksheets. You should write this down, because I don't want you to do all of it. And I will show you what they look like in a bit. This is the important part. You need to write this down, because I'm just going to tell you which ones I want you to do. So for sine ratio, I want you to do 1, 3, 5, 6. Some word problems. Question 1 is usually just solving using sine or cosine, right? For the cosine ratio worksheet, make sure you pay attention to this and write it down. 1, 3, 4, 5. Okay, that's the cosine. And for the tangent, I want you to do 1, 4, and 5. So question 1 for all of them, and then all of them question 5, it seems, right? They all share 5 in common. And now I will show you what those handouts look like. And if you don't have them, I will post them after I give you the instructions here. So make sure you have this written down, because I'm going to cover it up in a bit. And again, I can't force you. I'm not there at home, right? So you might be tempted to just be like, I kind of get it. But really, unless you try this on your own without help, right? If you're able to do this without help, maybe just looking at the study sheet and stuff, then you're in good shape, right? But if you need to look back in your notes or whatever, you understand the concept, it makes sense to you, but you're not ready, to come in and write an assessment of some sort. So here it is. I will show you. Okay, there are 3 kind of small booklets in your package. The first one, it's folded. It's folded. It's not stapled or anything, but it's folded. Okay. So the sine ratio, if I say do question 1 on that one, that means 1 A, B, C, D. So there's a bunch of triangles on the first page. You do that. Okay. So that's the first handout that I want you to find. It says the sine ratio. It says lesson 3 at the top. Then you have the cosine ratio. Okay, it looks like this, exactly the same. It's a folded, you can't miss it. It's not stapled, it's just folded. Look for that one. And the last one is the tangent ratio. Okay, so now that we've covered all three, sine, cosine, tan, we've done word problems. Now you should be able to do these questions. Okay, so I will just uncover again which ones they are I want you to do. Make sure you write the questions down because you can't do them all yet. And then you will work on that for the rest of today. Another nice thing about it is that the answers are towards the end. You'll find the answers there. So I'll show you. Right? If you look at the back, there's an answer section for every single one of those handouts. And you can check if you're on the right track. Okay. So that is it for today. I would don't hang up yet. Okay, don't hang up yet. Strongly encourage you to work through those. I will maybe go over a few of those word problems tomorrow, and there will probably be some kind of AC tomorrow on word problems. Okay. So have a good one. Take care. See you tomorrow at 2:10. Have a good one. You can sign off now. Yeah. Have a good one, Francis.